everyone, welcome back. Today we're going to talk about integration, integration three ways. Now the integrations that we are going to explore today would be integrations using partial fraction. We can check it out. Secondly, we're going to integrate that using substitution, right? And then lastly, we're going to apply a more advanced method on integration, which is integrations by parts. All right, let's check it out. All right, welcome back. Now we're going to start with the first methods of integration, integrations by using partial fraction. Okay. Now this is the questions that we're going to evaluate using integrations by partial fraction. Okay. Now how are we going to apply partial fraction onto these integrations? Now before we start, we have to check out the graph for this function here, just to make sure that the limits does exist when we have the lower bound and the upper bound for this function here. Now if you were to plot this function, you can see that it has two asymptotes, the vertical and the horizontal, at x equal to 0.5 and y equal to negative 0.5. Now based on our lower boundary and upper boundary, now that would fall around here, so we are trying to find the area from here 0 until somewhere like 0.25, should be meter here. Alright, now this is the area that we are interested to obtain through this integration, and then it does not actually fall into the asymptotes there, so we are okay to integrate this. Right, now let's get started. How do we integrate this using partial fraction? Okay, now let me erase this. We're going to work out the partial fraction first before we're going to start to integrate it, right? Now the partial fractions, let's consider this, right? Consider this expression before we start with the integration. Okay, so we will consider this as, alright, by considering this in this form, so you can write down a plus b over 1 minus 2x, for instance, right? This is one way of representing these improper fractions in the form of partial fraction. Okay, now there are many ways to actually represent this, right? But this is the easiest way, right? Now in order to solve for a and b, okay, now in this case I need to make a remark where a and b should be all real numbers. Okay, now in order to get a and b, there are many ways to do this. You can either use substitutions by substitute a suitable value for x, and then we should be able to obtain the value a and b, right? Or you can actually arrange these right hand side expressions into the form that looks very similar, like the one on the left, and then through comparison we should be able to obtain the value for, or the constant for, a and b. Okay, now here I'm going to use substitution instead. If you're interested to try out the comparison, by all means you can go ahead, right? So here I'm going to substitute, I'm going to say let x equal to 0, so I'm going to put in x on both sides. So when I put in x equal to 0, then I should expect a 0 on my left hand side, and then I would get a plus b equal to 0 on my right hand side. So that will be my first equation, and then after that I can sort of substitute. For instance, I can put in a 1. Okay, so I can put in a 1 here, so therefore my left hand side would be a negative 1, and then my right hand side would be a, and then by putting 1 here, I should yield a minus b equals to negative 1 here. Now that will be my second equation. By solving this simultaneously, I should have, okay, so take for instance, so I'm going to solve this simultaneously, and then therefore my A will be negative half. And then using either one of this equation, I should be able to obtain my B in this case, right? So my B is, let me see, if my A is negative 1 over 2, my B would be 1 over 2 here. Just let me check if I got it correct. Yeah, correct, right? So B is 1 over 2. Therefore, I have successfully obtained the partial fractions for this improper fraction that can be written in such a format. Okay, so my B is a half. Alright, there you go. That is my partial fraction. Now, once you have obtained the partial fractions, then we are ready to perform the integrations for this, right? And then after getting the integrations, the result represent the area under the curve from 0 to 0.25 here. Right, now I hope that is clear. Now I'm going to remove this. I'm going to show you how to perform the integration using the partial fractions that we have obtained here. Right. Okay, so from here, for this integration, okay, let me write this one down. For this integration, x so we can integrate that using this result, which is the same as okay, there you go. All right, now from here we can apply divide and conquer again. Therefore, we should have now the first part will be negative 1 over 2x. Alright, now this one here we can extract the half outside of the integration, and then by integrating this one here, okay, so therefore it looks something like this. Okay, now we can use a standard formula to integrate this, which would yield this result. Okay, now at this point I will try to simplify this so that it's easier to work with this at this point. So now when we substitute x equals 0, it will be 0. Therefore the result here will be 1 over 8. And then by using the standard formula for this, I should have, okay, because this one will yield a ln here, therefore is 1 over 2, negative 1 over 2, so that will be negative 1 over 4. And then that should yield ln 1 minus 2x. Preferable we put a modulus sign here in order to avoid math errors when we calculate ln that involve a negative number here. And then there you have it. That will be the definite integration here. And then finally all we need to do is just substitute the upper bound and the lower bound. Okay, let's see what do we have here. Okay, if we put a quarter there, then that will be a half, so there will be a ln half here. And then we put a 0 there, that is a 0 because ln 1 is a 0. Therefore this is the only result that we have. And then furthermore we can simplify this into this form, because this ln half is actually negative ln 2, so therefore we can actually write it down as ln 2 like this. Or based on my personal preference, I prefer to write the positive number in front, and then at the back it will be this here, right? Now I hope that is clear. The first methods, integrations using partial fractions to evaluate this particular integration. So I hope that is clear. Now next, stay tuned. I'm going to show you how to integrate the same expression by using substitution. Alright, welcome back. Now I'm going to show you how do we evaluate this using substitution. Okay, let's get started with this. Now there are many ways to substitute this, but I find that the easiest way is to do it this way. So I'm going to let u 1 minus 2x because it's all about u. Alright. Okay, now from here we're going to follow the standard procedure. We're going to differentiate this with respect to x. So therefore I'll get a negative 2 here. And then if for some of you who like to arrange this in this way, for instance, you let your dx as the subject in this case. So therefore there will be negative half du. Then we are almost done. And then we are also going to change the upper bound and the lower bound. So when for x equal to 0, we're going to evaluate the u. So x equals 0, the u become 1. And then when x is equal to quarter in this case, so the u will be a half. Right? It's very obvious in this case. Okay. Now once you are ready with this, okay. Now there's one more sections that we need. Okay, because we need to represent the x in this case. So therefore, the x can be written as half 1 minus u. Okay, so let me check whether that is correct. Okay. So once we have this substitution, we have the transformations with regards to the differentiation, and then we have the transformations with regards to the upper bound, lower bound. Then we are ready to perform the integration. Okay. Now therefore, this original integration can be written as in the form of u. Okay. So x, we know that x can be represented as half 1 minus u, and then our denominator will become u in this case. The dx itself, we have already transformed that, which is negative half du here. And then we have also transformed the upper boundary and the lower boundary. Now that will become from when x is 0, u is 1. So when x is a quarter, u is half. Okay. So this is 1, this is half. Okay, this is how it look like. And then by a bit of cleaning up, we should have this one here. We have 1 over u minus a 1 du here. 1 half. Okay. Now in this case we can simplify the u. Because u is not equal to 0 within this lower boundary and upper boundary. Okay, so we are cool with this. Now from here, okay, I'm going to continue it over this side so that you can see how it look like in this case. So I'm going to continue from here. Now that would be, in this case, it would be negative, okay, negative quarter. We'll continue from here. So negative quarter, 1 over u minus 1 du, 0, oops, I keep on writing 0. It's supposed to be 1 and a quarter and a half here. Okay. Now integrating 1 over u is basically a ln u, and then this is just u itself. Okay. Alright, now basically we are done. All we need to do is just substitute the appropriate upper boundary or lower boundary. Therefore, let's see whether we get the same answer as before. Okay, we have here a ln half minus a half, and then okay, and then subtract off with ln 1 minus a 1. Okay, so from here we will have, we know that ln 1 is 0, so therefore only left with positive 1. 1 with this a negative half will become a half itself. So therefore you have, and then this one we can change it to negative ln 2. So therefore, there will be half negative ln 2 in this case. And then by a bit of rearrangement, we get quarter ln 2 subtract off with 1/8, which is exactly the same result as what we have obtained using partial fraction. So therefore, this integration can be performed using partial fraction or through substitution. Now, I hope these two technique is clear to you. Right now, stay tuned. I'm going to show you a more advanced method of how to integrate this using integration by parts. Stay tuned. All right, let's explore the last methods to integrate this using integration by parts. Okay, let's get started with this. All right. Now, I find that it's easier to integrate by parts through this arrangement here. So take for instance, in this case, I would let my u equal to x, and then my dv dx equal to my 1 over 1 minus 2x. So I find that easier to perform integration by parts using this configuration, right? So from here, I will be able to get my du dx equal to 1. And then my v, through integrations, I should have negative half ln 1 minus 2x. Yeah. Okay. And then I'm going to apply the integration by parts. Now at this point, I try not to substitute the lower boundary and upper boundary first. I will do that at the end. Right? So therefore, this one here can be written as, based on the formula itself, it's supposed to be uv subtract off with v du dx, and then another dx integration. Right? So by substitute this through the integration by parts formula, I should be able to have, alright, now in this case I should have x over 2 ln 1 minus 2x modulus here. Right. And then after that, this one will be a positive half ln 1 minus 2x dx. Okay, right. Now that's my result here. Okay, now before I can continue with this, I'm going to make use of one result of integrating along. So I'm going to make a remark here. I'm going to make use of one of the result of integrating a ln function. So that result is this. So I have integrating ln x is actually given by x ln x minus x plus a c actually. So here I omit the c. I am just interested to obtain the result for this integration at this point. So it's x ln x minus x there, right? Now, if you look at this format here, this is also integrating ln, but in this case, this is more like an x itself. So through a bit of substitution, okay, I should be able to apply these methods here. Okay, let me show you how to do this without using substitution, even though I embed the substitution inside there. Okay, so that will be okay. In this case, I can actually write that down as, so in this case, I can write down as, let me see, what do I have here? It should be ln x. Let me see how am I going to write this. Okay, so I can actually write this as a negative half. Okay, negative half. Let me see if I Okay, so maybe it's best if I show you how I'm going to do it separately so that you can check it out more clearly. So in this case, I will let my u equal to 1 minus 2x. Okay, so 1 minus 2x, and then therefore du dx is equal to -2. Okay, and then indirectly it's very much the same as before, so that will be du over 2. Okay. Okay, and then all I need to do is just substitute all this into here. Therefore I would have this would become a ln u instead. Okay, and then dx is basically negative half du, so negative half du, so I might want to change this directly. So just let me change it directly so it's easier. So that will be negative quarter, and then integrating this with respect to du, and then making use of this result, I would have okay, so this whole result is given here. That will be a u. There will be a u ln u minus u. So instead of u, I'm going to substitute all this. That will be this ln u also, and then a minus of u, which is this one here. Okay, and then there you have it. That will be the result of my integrations here. Okay, and then after this, I'm going to include the lower bound and the upper bound now. I'm going to say that therefore my integrations from 0 to quarter here can be given as, so all I need to do is just substitute all this. Lower bound and upper bound into my first expression, and then there go the same second expression also. Okay, right, and then there you have it. Okay, now I'm going to pause here for a while, okay, and let you get an idea of the result. I did not actually simplify some of this expression, so all I need to do is just substitute all this value inside, and then let's check whether I'm able to obtain the same result as before. Alright, now I'm going to pause there, and then I'm going to continue from here. Okay, now let me erase the rest on top. We don't need the rest anymore, so we don't need this. Okay, now we don't need this anymore. Right, I'm going to write down the result that I have currently for this. Can be given by negative x over 2 ln 1 minus 2x subtract off with a quarter it's a long expression here. Okay, there you have it. Let me clean up the rest. Okay, don't need this anymore. Alright. Now we're going to try to substitute all this value in, and then hopefully we can get the same result. Okay. If you put in 0 here, definitely it's a 0. So I'm going to substitute my quarter first. So there will be 1 over 8. This one must be a half here. Okay. And then I'm going to proceed on with the second one. Okay, so if I put in 0 here, generally I only have this part will be a 0, so I only have -1. So I'm going to put in quarter first. So quarter, I will have a half here, ln half, okay, and then minus of this is also a half. Okay, that's my first, and then after that I'm going to substitute my lower bound. Okay, if I put my lower bound here, this is 0, and then this one is a 1 here. Okay, and then after this I can simplify this. This is basically 1/8 ln 2, and then here I will get a -3/2. Okay, this one I can write down as -1/2 ln 2 -3/2. And then after that I will get from here I get 1/8 ln 2, and then after that I will have 3/8 here, and then from here I will get 1/4 ln 2 plus 3/8. Okay, just let me check if I got everything correct. Let me see. Is that correct? It's positive. I noticed that this number is not really what we got previously. What we got was just let me check here. Let me pause for a while. Alright, now after checking through, I noticed where the error is. Okay, so from here, when I substitute my lower bound, it's supposed to be here. Just let me correct that. I'm going to highlight this in my working here so that you can also see where the error is located. So here, my error is supposed to be, when I substitute my lower bound, it's supposed to be 0 minus 1 here. This is where my error is found. So I put it in blue color. Hopefully in the future it remind me of this error. So therefore this is actually +1. So +1 with this, I will get a half. So it's supposed to be a half in this case. So I'm going to change the color. That one will be +1/2. Okay, from here, if I perform this calculation, that is correct. So it's 1/8 ln 2, and then the final one is actually negative. So this is yet another error. So that is negative 1/8 there. So from here, if I simplify this, it's 1/4 ln 2. Yes, correct. And then the final one, yep. I'm going to revise my working here. So therefore, is -1/8. Now therefore, it's exactly the same result as what we have obtained through the other two methods, by partial fractions and by substitution. So I hope that this has been a good learning journey for you. Don't forget, if you like what you're looking at, do press the subscription button, and then don't forget to turn on the notification bell so that you can receive the latest video that I'm going to post up. Right? Thank you very much for watching. Until I see you again, stay healthy and stay safe. All right? See you guys again.